Hey guys, we're going to look at Day 6 notes today for Unit 8. We're going to look at factoring and dots. If you look here at number 1, 2, and 3, this is the warm-up, so it just says factor the following expressions. Go ahead and take a second, factor those out, and then we'll come back and talk about them. Alright, here are the answers to numbers 1, 2, and 3 on the warm-up. Please make sure you check those. If you have any questions, pause it and look through them. Alright, so let's go on down here to where it says dots means. Dots, D-O-T-S, means difference of two squares. So let's take a second and talk about what that is. Difference is talking about subtraction. Okay, the difference between two items is when you subtract them. Here, I want to subtract two squares. This means things that are perfect squares. Okay, things that are perfect squares are things like x squared, 4, 9, 49, 100. Okay, these are all numbers. Let's even write down 1. Okay, these are all numbers or terms that are perfect squares. That means that there are two numbers exactly the same, or two variables exactly the same, that when I multiply them together, I get those terms. Okay, so I'm going to need those important terms in order to do a dots problem. So let's look at example 1 here so we can see what that really looks like. Number 1 says x squared minus 81. Well, first off, we do have a difference, so we are using subtraction, so that's good. Next thing I want to look for is that both of those terms, the x squared and the 81, I need to make sure that they are perfect squares. Well, x squared is a perfect square. Okay? X squared is the perfect square of x. X times x gives me x squared. 81 is a perfect square of 9, because 9 times 9 is 81. So when we factor this, I need both of those perfect squared terms, the x and the 9. So what we do is we write two sets of parentheses for our two factors. The x, which is the perfect square of x squared, goes in the first spot for both of those. Because if I multiply x times x back together, I'm going to get x squared. The 9 is going to go in the second place, because 9 times 9 would give me that 81. Now the only trick is 9 times 9 is a positive 81. I need that 81 to be a negative. So we're going to make one of these positive and one of these negative, so that when I multiply that positive and negative back together, I actually get that negative 81. So this right here would be the factors of x squared minus 81. If we wanted to check it, we can definitely check it. So let's just check it just to show you on this one. So x plus 9 times x minus 9. I'm going to use distribution, so I get x squared minus 9x plus 9x. What are we noticing that's going to happen with those middle two terms? And then minus 81. So indeed, those middle two terms are going to cancel, leaving us with x squared minus 81, which is what the original problem was. So we know for sure that we got those factors correct. All right, let's do the same thing for number 2. So yes, it's subtraction, so that's good. P squared is the perfect square of p, and 100 is the perfect square of 10. So when I write my factors, we write two sets of parentheses. The perfect square of p squared goes in the first spot, and the perfect square of 100 goes in the second spot. One gets a plus and one gets a minus. It does not matter if I put the plus first or the minus first. It all works out the same. All right? So let's look at number 3. Number 3 says m squared plus 36. So I'm going through my questions. I want dots. Dots is the difference of two squares. Okay? Is number 3 a difference? No, it's not. That's a plus sign, not a minus sign. So right here, the problem itself is already factored, so we can put not factorable. Okay, because it's already in its simplest form. Okay, we can't take it down any farther. All right, so take a second, go ahead and do number 4. All right, so here's the answer to number 4. Check it and make sure you got it right. Okay, now let's look down here at number 5. Okay, number 5 and number 6 look a little bit different, but we're still going through the same process. So we want to say, is number 5 a difference? Yes, we've got subtraction. Is the first term a perfect square? Well, I need to make sure that all pieces are perfect squares. All parts must be perfect squares. Okay, well, is 4 a perfect square? It is, of 2. And x squared is a perfect square of x. 81 is a perfect square of 9. So you're going to see that the first term of each set of parentheses is actually going to be a 2x now, not just the x. And the second term of each set of parentheses is going to be a 9. Still keep the same rule, one gets a plus, one gets a minus. Again, if you want, you can check it by distributing or doing a box to multiply it back together. Okay. Number 6 is a little bit different than number 5 just because this piece right here. You need to make sure you understand that 1 is perfect. It definitely is a perfect square because 1 times 1 gives you 1. So 9 is the perfect square of 3, p squared is the perfect square of p, 1 is the perfect square of 1. So I'm going to have a 3p plus 1 times a 3p minus 1 for those factors. Okay, so let's move on. Go ahead and take a second, do number 7. All right, here's the answer to number 7, 4m minus 5 times 4m plus 5. Okay, when we look at number 8, this one is actually going to have a couple extra pieces. So we see that 100x squared minus 49y squared. So we see we got x's and y's. That is okay as long as everything is still perfect squares and we're subtracting. So yes, we are subtracting. We see that right there. And 100 is the perfect square of 10. X squared is the perfect square of x. 49 is the perfect square of 7, and y squared is the perfect square of y. So everything is a perfect square, so that means we can still go ahead and write this as a dots problem. So 10x plus 7y times 10x minus 7y. Okay. When we get down to number 9, we're going to see something else that changes here just a little bit. Okay. When I start asking questions, I say, is it subtraction? Yes, it is. So now I need to say, is everything perfect squares? Well, I'm looking at the number 2, and I know for sure 2 is not a perfect square. So before we jump the gun and say that this one is not factorable and that we can't do anything, we always need to go back and ask ourselves, is there a GCF? Is there a greatest common factor between 2 and 72? And hopefully we all agree, yes. The GCF here is 2. So that means I can factor out a 2. When we factor out a 2, if you like the division, you can think about it like the division. That's going to leave us with m squared minus 36. Okay. Now we can go and ask ourselves, do we have a dots problem? So when we look inside the set of parentheses, yes, I still have subtraction, and yes, now I have a dots problem because m squared is the perfect square of m, and 36 is the perfect square of 6. So we have our GCF of 2 on the outside, and then we have our 2 sets of parentheses, which give us an m plus 6 times m minus 6. Okay, So I'm going to go ahead and do number 11, then I'm going to have you guys do 10 and 12. So number 11, okay, this one has 4 terms. So I can't do dots because it's not just 2 terms. It's not a binomial. It actually has 4 terms. So we got to think back to what we did before, which is grouping. So when we do grouping with our 4 terms, we're grouping the first 2 and the last 2, and now we are going to factor out the GCF from each group. So x squared, leaving us with x plus 6. Then here, don't forget, we have to include this negative when we factor out that GCF. So negative 9, leaving us with x plus 6. Okay, that sign changes for that 54 because of the minus that we factored out. Now we're going to regroup. So regroup our GCFs together, x squared minus 9, and then the factor of x plus 6. We only write that once. Now, when we get to this step, we need to ask ourselves, do I have dots? I do have dots now. Okay. So we have dots. That's going to give us x minus 3 times x plus 3. And then we still need that factor of x plus 6. So this one we had a grouping, and then at the end, when we got to this step right here, we needed to look and see if we could do anything else, which we could. We could factor it down using dots. Okay, so go ahead and take a second, go back, do numbers 10 and 12. All right, here's the answers to number 10 and number 12, so please take a second, check those, make sure you understand them. All right, if you have any questions, please talk to your teacher. Have a good day.